Today, we wish to continue our work about angles formed by when two lines are cut by a transversal. Specifically, today we want to talk about when two parallel lines are cut by a transversal. Our objective, we will learn about the angle pairs formed when parallel lines are cut by a transversal. Our standard, it's the same standard we've been working with for a while. We'll just do the highlighted parts today. That when a transversal crosses parallel lines, alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. Also, same side interior angles are supplementary. So to begin today's lesson, let's review the angles formed by a transversal. Corresponding angles, two angles that occupy corresponding positions, such as 2 and 6, 1 and 5, 3 and 7, 4 and 8. The other ones that we learned yesterday, alternate interior angles, like the ones in red, alternate sides of the transversal and they're interior of the parallels. Your same side interiors on the same side of the transversal and interior of the parallels. Alternate exteriors, alternate sides of the transversal and they're exterior of the parallels, like what's in blue. This is one that we didn't really talk about yesterday, but it is a pair. The same side exterior angles outside the parallels on the same side of the transversal. Well, let's start. And this whole thing hinges on this fact, the corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are congruent. So in our diagram, if the lines in the diagram to the left are parallel, then the following pairs of angles are congruent. 1's congruent to 5, 2's congruent to 6, 3's congruent, that should say 7. 3's congruent to 7. And 4's congruent to 8. Next, let's talk about the alternate interior angles. Notice this is a theorem, which means that it has to be proven. Given that L is parallel to M, prove that angle 3 is congruent to angle 6. Well, if L is parallel to M, 2 and 3 are vertical angles. So by last chapter, the vertical angles theorem, 2 is congruent to 3. If the lines are parallel, which is what we're given, that means that 2 is congruent to 6 by the corresponding angles postulate. And if you remember, we had that theorem at the end of chapter 2, that if two angles are congruent to the same angle, that means they're congruent to each other, or the transitive property of congruence. 2 is congruent to 3, 2 is congruent to 6, therefore 3 is congruent to 6. Here's the alternate interior angles theorem written out. If parallel lines are cut by a transversal, then alternate interior angles are congruent. 3 is congruent to 5, 4 is congruent to 6. Take a look at example 1. Find the value of x if A is parallel to B. 5x minus 54 equals 3x plus 16 because they're alternate interior angles. From there, we're just doing an algebra equation. We'll still subtract 3x on both sides. Then we'll add 54. And finally, we'll divide by 2. And we discover that x equals 35. The key for our geometry lesson today is we have to recognize that these are alternate interior angles, and they have to be set equal to each other because they're congruent. Next, alternate exterior angles. Two lines cut by a transversal are parallel, then alternate exterior angles are congruent. So if M is parallel to N, then 2 is congruent to 5. Same kind of reasoning. 2 and 1 are vertical angles, so they're congruent. 1 and 5 are corresponding angles, so they're congruent. So since both 5 and 2 are congruent to the same angle of 1, therefore 2 is congruent to 5. Same side interiors. This is the only one of these that's different. Notice that 4 and 5 form a linear pair, so 4 plus 5 equals 180. But 5 plus 5 is congruent to 1, so we can replace 5 with 1. And thus we prove if two lines are cut by a transversal or parallel, then same side interior angles are supplementary. Again, same side interior angles are the only angle pairs that happen to be not congruent. Let's look at example 2. What are the measures of angle 8 and angle 4? Explain. Well, notice that A is parallel to B, which is indicated by these arrows in the middle of the lines. That means 8 and 115 are same side interior angles, and they have to be supplementary. So angle 8 is 180 minus 115, or 65 degrees. But since M is parallel to N, indicated by these arrows in the middle of these lines, 4 and 115 are corresponding angles because they occupy the same position, which means that angle 4 would equal 115. Find the measures of angle 2, angle 7, and angle 8 if the two lines are parallel. So angle 8 would have to equal 53, since it's an alternate exterior angle with the 53-degree angle. Angle 2 is 127, 180 minus 53, because it forms a linear pair with 53. Angle 7 would also equal 127 because it's an alternate exterior angle with 2. Again, notice they alternate sides of the transversal, and they're outside of the two parallel lines. In our last example, we have to use the value of x, then use it to find the measure of each angle. So your task, again, notice the arrows in the middle of the lines indicating that they're parallel. What special pair of angles are these? They are the same side interiors. What's the relationship? They're supplementary. And that's the task that you have to do. Recognize what special pair of angles you're given, and then use the relationship. So since that means they add up to 180 because they're supplementary, we get 4x plus 40 equals 180. 4x equals 140, thus x equals 35. Then we'll plug in that 35. 2 times 35 plus 43 equals 113, and 2 times 35 minus 3 equals 67. Notice that 113 plus 67 add up to 180, thus making them supplementary. And that concludes today's lesson.